All right. Good morning, ladies and gents. This is April the 13th, and this is variation. Variation is just a relationship between two variables. It talks about how do two different variables affect each other when they're applied together. So, you have direct variation, which looks like this: y equals k times x, where y and x are two variables, and k is your constant. It will stay the same throughout the entire problem. You also have joint variation, where you may have three different variables where they're all being multiplied. Sometimes you'll see me put the dot in between those, sometimes not. Either way, it is all multiplication there. So that would be y, x, and z that we are using as a variable. Lastly, we have inverse variation. With inverse variation, our variable is going to be on the bottom, in the denominator, if y is inversely proportional, then you are going to divide. So pretty much a good example of this to kind of help you understand what variation is for direct variation. Think of hourly wages. So say you work at the grocery store and you make, $10 an hour, which is awesome. That must be a really nice grocery store. But the more hours you work, the more money you're going to get, right? So they both go in the same direction. Whereas the less hours you work, the less money you're going to get, right? So those are going in the same direction. If I was in class with you right now, I'd be raising both of my hands. As one goes up, the other goes up. As one goes down, the other goes down. Now, inverse variation will be a little different. Inverse would be as one goes up, the other goes down. So in other words, think about speed. If it takes you 30 minutes to get to Raleigh, if it takes you 30 minutes to get to Raleigh, but you increase your speed, say it takes you 30 minutes to get to Raleigh and you're going, 55 miles an hour, and then you decide to get risky and increase your speed and go 65 miles an hour, you're going to get there in less time. So as your speed goes up, the time it takes to get there is going to decrease, right? Or the opposite. As your speed goes down, the time it's going to take to get there will increase. All right, so, and then we have that k. K is the constant of variation that will always come after the equal sign. So for number 1, you can see that our k here is 2, and this is direct variation. We have one variable that we're using on the right side of the equal sign, and we have our constant of variation. For number 3, our k will be 5, and we have joint variation here. There are 3 variables. We have y, x, and z, so there's 3 variables there. For some of these other ones down here, and for number 2, I'll go ahead and do that one. That one is inverse. K is 24. Again, we know it's inverse because the variable is on the bottom. Okay, let me see if I can find one where... Yeah, this would be a good one. Looking at number 8, for some of these, you just have to solve out. So for number 8, they're just asking you to solve out for A. And this might be familiar to you, but this is area equals 1/2 base times height. This is the area of a triangle. But this is not inverse variation because we do not have a variable on the bottom. Instead, we have a number on the bottom. And that number right there could be placed as a 1/2 times b times h. So this is joint variation where our k is 1/2. You will see that, and be very careful not to call that inverse just because you're dividing. That one is technically, you could write it as multiplying by a fraction for our constant of variation. For number 4, it's the exact same way. I didn't see this one. I could have done this one first. But we divide by 3 both sides, and that would be y equals x over 3. Now again, this is not inverse variation. Since we do not have the variable on the bottom, instead we have our coefficient on the bottom, which we can rewrite as 1/3 x. And now that looks like direct variation. And it is. So be very careful with that, not to get inverse and direct confused. So with direct variation examples, we're going to have 2 different examples And they didn't give us our constant of variation here. So we're going to have to find the constant of variation and then plug it back in to find another case. So if y is directly proportional to x, and y is 28 when x is 7. So you see they didn't give us k. That's what we're trying to find. So we would divide both sides by 7, and k would give us 4. Now, the next thing I want you to do every single time is plug this k, back into the equation. So now you have y equals 4x, just like that. And that's our new equation. And they will give you one of the variables and ask you for another. So it says to find x when y is 52. So we would do 52 equals 4x. We would divide both sides by 4. And that example would give you 13. Right, so you see there's two different equations here. The very first thing we do is write down the equation and plug them in, solve for k, set up that new equation, and then solve again. So that's kind of your 4-step process to start out. So for number 10, we'll do the same thing. Now, they're not doing something that's as simple as y equals k times x. Excuse me. They're asking you to change it up a little bit. So if r is directly proportional, so in other words, directly proportional means we're going to multiply, and k, our constant variation, always comes after the equal sign. Always. Do not forget. R is directly proportional to the square of s, so that will be s squared. We're not doing the root sign, the radical, because it doesn't say square root. If it said square root, we put the radical sign. If it just says square, you're raising it to that power. So there we set up our equation. Now we plug in 72 and 12. And we're going to solve for k. So that's 72 equals 144k, and k will equal 1/2 when you solve that out. So now we set up our new equation, and we plug in k, so that's 1/2, r equals 1/2 x squared. We found our constant of variation, now we just plug it in. And it says to find r when s is 8. So we'll do 8 squared, which is 64. Divide that, or multiply by 1/2, divided by 2, which is 32. There's your answer there. Okay, so this is a good example of direct variation. The dollar amount that Megan earns varies directly with the number of hours she works. So sometimes they'll give you these little variables right here. That's really nice and neat. Sometimes they won't. So kind of be looking out for what two things we are comparing here. So the dollar amount, D, varies directly with the hours she works. This is like what I was talking about earlier. In her last paycheck, she earned $148.50, and she worked 18 hours. So if we do 148 divided by, or 148.5, I didn't even write it, divided by 18, let me grab my calculator real quick. Should have been prepared and already have this out. Okay. 148.50 divided by 18. That will be her K equals 825. So that right there is how much money she makes per hour. That's our constant of variation in this problem, $8.25. So we set it back up and plug in K. And then with that, we will plug in our last thing. If our next paycheck is $90.75, how many hours did she work? So 90.75 divided by 825 will tell us how many hours she worked, and that was 11 hours. Okay, so there is direct variation. Now we'll do a couple with the joint. I'll just go straight to the more difficult ones. If P varies jointly, always put the K, varies jointly as Q and the cube of R. In other words, R to the third power. And P is 270. We don't know K. We're going to find it. Q is 6. R is 3 cubed. So 3 to the third power will be 27. I'll multiply that by 6. And that will give me 162. 270 equals 162K. 3 to the third power. Yep. And then I'll divide by 162. And that should be 5/3. Once you simplify it out completely. So again, we take our k and plug it back into our original equation. And now they will leave one variable missing here. So find p when q is 3 and r is 5. So these 3's are going to cancel out right here. So it's really just 5 to the 4th power, and that will be 625. So our final answer here is 625. There you go. All right, this joint variation right here might be my favorite problem out of the whole semester, because usually I will sit there and give you a whole discussion about interest and banks and loans and how I'm paying off my RAV4 and how you need to be smart about all that. And I'm really close to it, actually. But alas, I won't be able to do that. I just said the word alas. Man, I'm getting really old. Okay, so for Tom's saving account, the interest varies jointly with the principal and the amount of time since opening account in years. So those are the things we're talking about. So the interest varies jointly with the principal and the amount of time. So we'll put time there. So what we mean by principal is how much you put in, how much you have given the bank, not the interest. So if you put in $500 into a bank and over a year the interest you earn is $5, you would have $505, right? But the principal is still $500. That's how much you have put into the bank. So that's what we're talking about with principal. So if Tom opened the account 3 years ago with $1,200, that's the principal, and it earned $144 in interest, and we know it was 3 years ago, we're going to find our interest rate there. So that will be $3,600. We divide both sides by $3,600, and that will give us our rate, which, if I'm not mistaken, is 4%. That's how much I like this problem. So we'll take that and plug it back in. 4%, which is really, really good, times the principal times the time. So how much interest will he have earned? So in other words, we want to know interest. 8 years after opening the account. So we know that the time is 8 years, but you may be asking, wait a minute, they didn't give us principal. Well, the principal is how much you put into the account. So Tom didn't add anything else over those, or since that 3 years, or over those 8 years. So that principal stays the same. It's still $1,200. So then we will take the 8, multiply it by 1,200, and multiply that by 0.04, and that should be $384. All right, cool. So